Last time, right? Api, okay. Last time we went through field to acceleration, but we had to go through some more examples. Okay, we'll do few examples on this. Then uh, we have to do some examples from pulley systems because there will be two problems from this section. One, either 12A or 12B. Other than that, we get a problem in the first paper, third or the fifth. Most of the time, the third. Right. Anyway, first we have to go through some more examples. Right. Okay. There's a wedge like this. So there are two masses placed like this. M these two M, and the mass of the wedge. Hold on, AB6A. Right. Let the mass of this be 4M. Right. Obtain sufficient equations to find the time taken, sorry, for the wedge to collide with this wall. The distance is A. Right. Okay. First, we have to mark the accelerations and stuff. So there are three objects. Uh, Now, this is moving on the table. So its acceleration is related to the Earth. Like when you apply F equals ma, the acceleration should be related to the Earth. So we'll First, take care of that part. Right. Let the acceleration of this be, since it is 2m, sorry, should be f. I take this acceleration as f1, this as f2. Now this acceleration is relative to the earth. So acceleration of 4m, the wedge, related to the earth. It is this. Then these accelerations are related to this 4m, the wedge. So next one. Now this is the mass m. This is the mass 2m. So the acceleration of 2m related to not the earth, related to 4m. It's extremely difficult to write with this pen. Just hold on. Right. Now this is something like this. Then in the same fashion, the acceleration of m relative to 4m is this. Right. Now, these are not sufficient for us because we need the acceleration of these two objects relative to the earth. So you can insert 4m in between. Now this is, you have it here. So you have to consider both components. This is capital F. Again, if you want to find this, you have to connect via 4m. Right. Now, the acceleration of m relative to 4m is this. That is capital F. Now we are done with that part. Now we'll draw a diagram. I'll draw it here so that I can write the equations around the diagram. But you have to do it just one below the other. Right. Now this is 4mg. This weight is mg. Hmm. Now reactions. I'll take this as S1 because its mass is m, 1m. Here I'll take this as S2. Then okay, these are the forces. There's one more. The reaction between the table and the wedge. Then we have to mark the accelerations with the double arrows. Otherwise, it may lead to a confusion. These are the accelerations of simple limb, the mass simple limb. I mean, we use these accelerations here. I mean, if is added to every small object, every particle, and we have to consider this as well. So there are two components like this. Right. Now with this, we can write the equations. Now we'll see how to write the equations. There are three moving objects. Now this is the key. Three moving objects. How many accelerations are there? Capital lift, simple lift 1, simple lift 2. There are three, but there's one more. That is the tension. So there are four. So four variables and three moving objects. So there's a little problem because number of moving objects is the number of equations you can obtain without getting reactions involved. Like reactions nathu gandapulang equations gana. However, there are four variables. So it may not do any. It may not be a help. So therefore, we have to seek some extra help. So what is that? You don't have to seek an extra help, but instead you have to come up with the connection between these accelerations. So we'll consider this length because we are one equation short. So let's take this as x, this length of the like a straight portion of this string can be taken as y. Now first we'll take care of that. So x plus y is a constant, right? I'll write it here. Differentiating twice with respect to t, you get x double dot plus y double dot is 0. Now, if you, okay, f is directly related to v, because if is marked in this direction, if the object moves in that direction, in the direction indicated by f2, y increases. Therefore, those two have a positive relationship. So y double dot should be f2. Now here, if this takes the direction indicated by capital F, x is decreased. Therefore, it's a negative relationship. Now we'll plug in these values here. So these two are equal. So that's our first equation. Now that extra equation, the extra equation we need is this. Now you need three more equations. So for each particle, you can apply equations without reactions getting involved. So you can consider M and apply an equation in this direction. Applying F equals MA. For M. Now the forces, okay, SC is gone. No string is attached to that, but this is 90 minus alpha. So mg cos 90 minus alpha means mg sin alpha. Is this force, that's only force, is equal to mass is m. Now what's the acceleration? It is in this direction f1, and we have to resolve this, that is capital F cos alpha. So f1 plus capital F cos alpha. So you can divide this by simple limb. And this is equation 2. So I have two equations now. Anyway, you need to find capital F because we need to obtain enough equations to find the time taken for the wedge to collide with this. This initial length is A, right? 2. Now you need to at least obtain two more equations because we need to find F. There are four variables. To eliminate them and to find F, you need 4. Now apply another equation for this. So I'll do it here. Two M. Then again the same thing. 2mg sine alpha because 2mg cos 90 minus alpha, which is 2mg sine alpha minus t. Tension is in the other direction. Now you are applying the equation in this way. So it's equal to 2m times F2 is in this direction minus, when you resolve it, this angle is alpha. So capital F cos alpha in the opposite direction. So that is the equation 3. Now we need one more. We have to apply that for the system. Here, as we saw earlier, the pulley, you can separate this, you cannot separate the system here because there are some unknown forces involved. If you take that part in the system, then those two will go away. You can take something like this for the system. So, okay, apply Newton's law this way because if you apply this way, this R will go away. These are internal reactions. So if you take the system, those things will go away. System. Now, there are three masses. So what are the forces? These weights will not be involved in there. R will not come into the equation. And since they are internal reactions, they don't appear. But this T will be there. Now, instead of MA, you take the MA product. This is 4M. And its acceleration is F, capital F. Then if you take this, that is M, accelerations are okay, capital F plus simple M1 cos alpha, F1 cos alpha plus 2M. This is F. You apply the equation in this way. This is F2 cos alpha, but it is in the opposite direction. So you have minus F2 cos alpha. That's the fourth. Now, using these four, you can find F. Now, you need to find the time taken for the wedge to collide with the wall. So it is like this, and the initial distance is A. So you need you have the the distance, and you have the acceleration of this related to the earth. It is capital F. Now you apply S equals ut plus half at squared. Now this is A. U is 0 because initially the system is at rest. Half ft squared. So 2a over f is t squared and t is this. I'll take this as 5. Now by solving, you have to include this statement. 1, 2, 3, 4, and 5. the required time taken can be found. Okay, guys, you can take this down. Again, let me explain you. Here the number of moving objects is three, but you have four variables altogether. Therefore, we are uh, we are short of one equation. So first, you use the use differentiation to come up with that relationship. Then you regularly apply. In the usual fashion, you apply uh, Newton's law without getting reactions involved. So after obtaining the fourth equation, you should be able to find capital F. Now that's not it. You need to find the time taken for this to collide with the wall. So apply this equation as your fifth equation. Now once you know what F is, you can find the required time taken. Okay, you take that down. Okay, right. First, you have to mark the accelerations just to make sure that you know all the accelerations of all the objects related to the Earth. I'll take this as P. Now, uh, okay, the acceleration of this can be taken as capital F. I take this as F dash, F dash. Now, both are placed on the table. Therefore, the acceleration of 4m related to the Earth is this. The acceleration of m is a wedge. It's this. However, simple lift is the acceleration of p related to the wedge. This is alpha. Sorry. Hmm. Now you need to find the acceleration of p related to the Earth. So it should be like this. You have to connect it via simple limb. So this is right there. And then this is capital F. We need to find capital F, right? So it's not that bad, but we have to find it explicitly. So we'll do it like this. I'll draw the diagram here. This is 4mg. All the dashes are there for this 4m. Acceleration is like F1, sorry, F dash. This is capital F. This has two components. That's a tension. And there are there's a reaction in between these two. This angle is alpha. Now you can write the equations, right? Uh, Now we'll see. There are altogether three accelerations and one tension. However, there are only three moving objects, so we are short of one equation. Take this as x, take this length as y. So we can use differentiation or derivatives to find the extra equation we need. So we'll differentiate this twice. right? You have x double dot plus y double dot is equal to 0. Now you can see that uh, when it comes to simple if, that's only, I mean, y depends on simple if. If the object moves along that direction, y increases. So it has a positive impact. Now in this case, if these objects take the directions indicated by f dash and f, x decreases at the rate of the sum of these two. When they came along, if you take these two objects come closer. That means it reduces the value of x. It's exactly the sum. Hmm. Can make they come opposite directions. Therefore, since the directions are opposite, to get the relative value, you have to get the addition, get the sum. So the sum is related to x. But when these objects are moving in the indicated directions, then x reduces. So it's f plus f dash that is equal to x, but the negative in the negative sense, right? So x double dot is equal to f dash plus f. But both have a negative impact because both decreases the value of x. Say if capital F is negative, so this has a negative impact because when it goes to come, I mean, if it moves in the indicated direction, x decreases. Say this is still, if capital F moves in the indicated direction, that is that decreases, x decreases. Therefore, the sum, or you can take two negative values for both. Now you can substitute those. Minus f dash minus f is, sorry, plus f1 is 0. That's how equation 1. Now we'll apply Newton's law to these three. Now if you take this, for example, if you apply the equation in this direction, for m, you have t, that's only force because these are in the perpendicular direction of the application. For m is the mass and the acceleration is f dash. I take this as 2. Now I can apply another equation to P. This is mass P. Now, what are the forces? S will go away because it's perpendicular. This is mg, this is 90 minus alpha, so mg cos alpha, it's minus t. M times the acceleration. In the indicated direction, the accelerations are f minus capital F cos alpha. So that's the third. Now we need one more. That is for the system. Here everything is moving, therefore I can apply this horizontally for the system. Now, if you apply horizontally, R dash and R will go away. This is an internal reaction, and T is also getting cancelled because you are applying it horizontally for the entire thing. There's no wall here. If you have wall, then you have to stop it from somewhere here. But this is also moving. So if there's a wall is attached to some other parts. Therefore, we don't know exactly what the forces involved in the problem. That's why we exclude the wall. But in this case, we don't have such a problem. You can straight away apply Newton's law. So what are the forces? These three masses go away. T goes away. R dash and R will go away. This also, S will go away because there's an internal reaction. So the net forces is equal to 0. Now, if you apply it to this M, you have capital F. If you apply it to simple M, like if you consider, not apply, if you consider this, there are two accelerations, capital F minus simple F cos alpha. Here you have 4m. It's negative direction. When I write it like this, this is minus F dash. That's the fourth. You can divide it by m. So you have 0 is equal to, if you divide it by m, you get 2f. Then you have F cos alpha plus, sorry, minus 4f dash. Now, this is the best time, high time to eliminate one variable. We need capital F, right? Now, F1 is this, not F1. What is that? Simple F. It's simple F, not F1. But we have to do it carefully. When you add these two, you get both F dash, all F dash, F and capital F. So we'll remove this. For capital F, we'll write, sorry, for the simple F, we'll write F dash plus F. F dash plus F. Everywhere. Whenever you get simple F, we replace it by this. So from 1, whenever you have simple F, we replace it by F dash plus capital F. So you have 2F minus F cos alpha. Here you have minus F dash minus 4F dash. So it will be 5F dash. I take it as equation 4. Now you have to get rid of T. You can add 2 and 3. And whenever you have simple, if you replace it by this. So that's it. Then we can, now we have already removed T and simple if here. We get one more equation. We add these two. So then we can remove T. Right, when you add them, you get mg cos alpha in this side. In the right hand side, you have 4m if dash plus this m times simple if minus capital F cos alpha. You can divide it by simple m. Now we have a certain agreement. What is that? Whenever you see simple if, you replace it by this, just to reduce the number of variables involved in the problem. So g cos alpha is equal to 4f dash. Now, whenever you see simple f, you replace it by f dash plus f. So this should be replaced by f dash plus f. Hold on, something is missing here. This is not cos alpha. That is not cos alpha. When you apply it in this direction, this is 90 minus alpha. So cos 90 minus alpha is sin alpha. Everywhere you get cos alpha, but here you get sin alpha. So when you add 2 and 3, this should be sine alpha. Sorry. Now, for if you have to write f dash plus f, this g sine alpha. For f dash, this f dash plus f minus f cos alpha. So you have that. Now here, we get something simpler than that. Because here I have an expression for 5 f dash. Hold on, something is wrong. This cannot be this simple, right? This is fine, this right. If you apply this for 4m, t is equal to 4m f dash. That's fine. Here you have mg sine alpha minus t n times f minus capital F cos alpha. That's also fine. To f this way I have made the mistake. The simplification is wrong, right? Now, if you collect the terms containing f, capital F, you have 2 minus cos alpha, capital F. Here you have minus f dash cos alpha minus 4f dash. So if you bring everything to this side, that is positive f dash cos alpha plus 4f dash. So if you pull out f dash from this, you get cos alpha plus 4. Right. Now it's correct. Now when you apply, now I mean this is the main idea. Now you have 4 variables. Therefore, using this, you can eliminate one variable throughout. That means whenever you have simple if, you replace this. If you keep doing that, the number of variables will be reduced to 3. That's හතරක් තියෙනවනේ. මේ if dash දෙකම ගොම මේක දැම්මොත් එක කඩුවේ අඩුවෙලා යනවා. So number of variables will be reduced to 3. Right? If you do that, then automatically you can, I mean not automatically, but straight away you can remove t when you add these two. That's what we have done here. Right? That's what we have done here. Mg sine alpha, these two will go away, 4mf dash plus this. So you can divide it by simple m. Again, when you encounter simple f, you replace it by this. Right? Now this is what you have. 5f dash plus this. Now we have to replace f dash using this. I haven't labeled it. Right? 1, 2, 3. This should be 4. Right? Now, using 4, now look, I have now, throughout, I have replaced f by f dash and capital F. We directly replaced, I mean, eliminated t. Now you have these two equations in which you have f dash and f dash and capital F. Now you can easily replace, I mean, using 4, f dash is 2 minus cos alpha f divided by cos alpha plus 4. Now using 4, you can do this. 5 F dash is 2 minus cos alpha F. Capital F, sorry, divided by cos alpha plus 4. I mean, I have replaced F dash by, I mean, F dash in terms of capital F. Yeah, I have made a mistake there. Now I have corrected it. Maybe 5 කියලා F dash cos alpha එක multiply වෙන එක consider කරලා නැහැ. Now with this, you know, F dash is this divided by cos alpha plus 4. It is this. Now you have an extra term. Now multiply everything by 4 plus cos alpha, or cos alpha plus 4. I write it as 4 plus cos alpha. Here I have sin alpha. When you multiply this by 4 plus cos alpha, you get 5 times 2 minus cos alpha times capital F. And this should be multiplied by 4 plus cos alpha. Here you have 1 minus cos alpha times F. Here, if you pull out F from this, you get 5 times 2 minus cos alpha plus, here I have 4 plus cos alpha, sorry, 1 minus cos alpha. Now we'll simplify inside. This is 10 minus 5 cos alpha. Now if you multiply this, you get 4. You get minus 4 cos alpha plus cos alpha means minus 3 cos alpha. And when you multiply this, you get, now we'll divide. Now divide. This is 10, sorry, 10 plus 4 is 14. Minus 5 cos alpha minus 3 cos alpha. Minus 8 cos alpha. Then you have minus cosine squared alpha. This is the acceleration of the wedge. This is exactly what we need. Right. Okay, you take that down. I mean, when there are so many variables, this is how you have to do it. This is the hardest thing. Eliminate this variable. Wherever you see F, you replace it. So by doing so, you will end up with 3 variables. That is something which can be handled with a little much ease, I would say. Then when you add these two, T will go away. So you get only 2 variables, which are F dash and F. So make F dash the subject and replace it by capital F. So the only variable appear after that would be capital F. So you can easily solve it. Right. Now, systems of pulleys. Usually, this question will appear as a third problem from, I mean, in the first paper of applied. Now, it is like the same cases of the problems where wedges are involved. Number of movable objects or particles is equal to number of equations, like we saw earlier. Now, case one, where number of movable objects or particles is equal to n, and it is equal to the number of variables, means accelerations and tensions, you can apply Newton's law in times. Case two, this what usually, I mean, you don't get a problem of this type almost all the time. You get something like this because particles or objects, both uh, is equal to n. N is the number of equations. Here, the variables, if this is n plus 1, then we are short of one equation. So first, use derivatives, lengths and derivatives to obtain an extra equation. Then apply n times. You know, this is the extra equation. With these n equations, we have altogether n plus 1 equations. Now, no matter what the problem is, you have to first find. Now, this is the only difference between this type and the problems involved with the wedges. Here, you have to find the tensions. Hold on. Yeah, find the tensions first. You can easily find the tensions, but sometimes you can uh, no, you can remove tensions easily. It depends. It depends on the problem. Sometimes you can find the tension easily. Find the tension or the tension first. That would be easier for you. We'll do a problem. These are fixed. This movable. Okay. The question is find the tension. There's only one string. Now, here you don't have to mark the accelerations because all the accelerations are related to the earth. So that part is you don't have to worry about that part. Now this is M. So this mg, we can take the tension as T. I forgot to write mention the mass of this. Let that be capital M. Right. There are three movable objects. Now we'll mark the accelerations. We'll take this as F1. Since it is F2, 2m, I take it as F2. I'll assume that this goes up with an acceleration F. Now look, how many variables are there? 3 accelerations and 1 tension. However, there are only 3 objects. Therefore, you have to use uh, derivatives to find the extra equation. I take this length as x. This is this straight portion can be taken as z. Let this be y. Now, those are just lengths. We know that x, the straight portions, the length of the straight portions is constant. X plus cz plus cz plus y. It's a constant. So x plus 2z plus y is a constant. T. You get x double dot plus 2z double dot plus y double dot is equal to 0. Now, look at this. Now, if this mass moves in the indicated direction, x increases. So direct relation is there, x double dot is plus f1. Here again, if this object moves in the indicated direction, y increases, therefore this is plus f2. However, if you take this, if this pulley moves in this direction, it decreases. It's minus f, therefore f1 plus 2 times minus capital F plus F2 is equal to 0. So you have F1 plus F2 is equal to 2F. I take this as equation 1. Now we have to, we need 3 more equations. There are 3 movable objects, so you can apply Newton's law for each of them. So if you apply Newton's law for this, we always choose the direction of acceleration. That would be easier for us. For M, you have mg minus t is equal to mf1. That is equation 2. Similarly, you can apply Newton's law for 2m. It is 2mg minus t. Mass is 2m. The acceleration is f2. So I take that as equation 3. Now I need one more. So I'll apply an F equals ma to this. Now here, 2 forces are there, 2 tensions. So 2t minus capital Mg is capital M, capital F. That is 4. Now, look at this. T is everywhere. So it's hard to eliminate T. One thing you can do is that you can make F1 the subject, make F2 the subject using this, and make capital F the subject. In the previous cases, you can easily eliminate the tension. But here you can easily eliminate the free accelerations. That's the only difference between these two classes. The rest would be the same. If you do a problem involving wedges, involved with wedges, then after writing the equations, you can easily eliminate t. But if it's a pulley system or system of pulleys, then you can easily eliminate accelerations. Look, now you have F1, F2 is equal to F. Now replace F1 by T. Replace F2 by T. Replace capital F by T. So substituting 2, 3, and 4 in 1. Just to elaborate it, I write equation 1. Now, simple F1 is simple mg minus T over simple m. Simple mg minus T over simple m. Then F2, it is this. 2mg minus T over 2m is equal to, now this, 2T minus mg divided by capital M. So basically that's it. Now one thing you can do is to multiply everything by 2 simple M times capital M, or you can divide each piece by by this and then make T the subject. Both methods work. If you divide this by M, you get G minus T over M. Yeah, you get 2M to G minus T over 2M is equal to, this is 2T over capital M minus G. So if you bring G to this side, G plus G plus G, you get 3G. If you take the terms carrying T to the other side, T over M plus T over 2M plus 2T over capital M. Now you can pull out T. So you get 1 over M plus 1 over 2M plus 2 over capital M. Take this as the common denominator. So this is multiplied by 2 capital M. This multiplied by capital M, therefore multiply the upstairs by capital M. This multiplied by 2 simple M. So if you multiply this by 2 simple M, you get that. Now cross multiply. 6 simple M, capital M G divided by this. This is 3 capital M plus 4M is T. So in one shot, you can find tension just by eliminating F or the accelerations. Right, you take that down. We'll do some examples. Okay. We need to go through some more examples afterwards. So we'll take a little break at this point. We have to at least do three more problems like this. In which police are involved. Hmm? Okay. We'll take a break of nearly 30 minutes. Right. In the case of problems involved with wedges, you have to find the accelerations first. But here you have to find the tensions first. Tension most of the time. Okay. Now in this case, we'll find the tension. Or you can be asked something like this, possibly, write sufficient equations to find the tension. Hmm. Okay. Right. We can mark the acceleration. So I'll take this as F1. We'll take this as F2. Then the tension. So we have three variables, tension, F1. So there are three variables, but we have only two movable objects or two objects which are moving. So we are one equation short. So write these lengths x, then take this length as y, take this length as L, and it is fixed. This fixed point, the ceiling, the the height of this or the position of this pulley is also fixed. Therefore, this length is fixed. However, if you take the straight portions of the tension of the string, you have x plus y, then you have L. Since the string is inextensible, right? So this is a constant. So x plus 2y plus L is a constant. So by differentiating this with respect to t or time, you get x double dot plus 2y double dot plus 0. This is 0 because it's a constant, is 0. Now we can write it like this: x double dot plus 2y double dot is 0. Now, if this object takes the indicated direction, if you want, you can write it like this. Uh, X will go down. Therefore, it has a negative relationship, minus F1. But if F2 takes this direction, Y increases, plus F2. So you can come up with the first equation, that is minus F1 plus 2 F2. So F1 is, if you take F1 to the other side, 2F2 is F1. That's the extra equation. Now you can apply Newton's law to these two. If you apply Newton's law to this, I have forgotten this. R, and this is 3mg. This is mg. So if you apply it along this the string, or along the inclined plane, okay, for m, you have t minus mg sine alpha, because this is 90 minus alpha. Cos 90 minus alpha is sine alpha. So t minus mg sine alpha is equal to m times f1. That's 2. Now, the third, you apply it to this. So you have 3mg minus 2t, 3m times f2. Again, the same thing. I mean, you can find everything once you know what t is. Right? If you know what t is, then you can find f1. If you know what this is, you can find f2. So how do you find this? Now take this equation, make f1 the subject. F1 is this divided by simple m. F2 is this divided by 3m. You go ahead and substitute that there. Substituting 2 and 3 in 1. So this is, F1 is t minus mg sine alpha over m. This F2, this is F1. F1 is t minus mg sine alpha, over m. F2 is 3mg minus 2t over 3m. So if you divide this by m, I mean, here you don't have to do that. We'll divide this by, we'll multiply it by m. Now cross multiply. This is 6mg minus 4t. Here you multiply it by 3. 3t minus 3mg sine alpha. So if you add this up, it will be 7t. This is 6mg plus 3mg sine alpha. Now divide this by 7. So that's a tension. So we'll do one more. Oh, first you can take this down. And in fact, I miss you guys because these days now we don't physically meet. So, you are not, we don't meet in a physical setting. Therefore, I think if this goes on, we might miss a lot because, uh, sometimes you may postpone watching the video, or probably you may continue with certain mistakes. I don't know what to do with that. Possibly we have to find another time until this is resolved. Um, so if you if you suggest a possible time, I don't know, probably we have to wait at least for two weeks for that, because I have to find the availability of classrooms. If we come up with some available time, even in the morning, then we can meet and do that. Do the I mean, while doing this part, we can do some other topics as well. If not, if we cannot find an extra time, uh, I can have some online sessions. Like I can have some YouTube lives, because anyway I have to do uh, binomial expansion and matrices. Even earlier, I had plans to do that. And on top of that, I have to do either stat or probability online, mm, in some extra session, not on Wednesday, right? Because if you do stat and probability as well as the other one, what is Bose rotation, then we'll be like 4.5 problems. We'll be done with 4.5 problems. We have to finish those everything by 30th of April. Mm. At least we have to cover 5 problems by then in applied. Somehow we have to do it, right? Otherwise we have to rush through towards the end. That's bad. So we have to finish, like, you know, in problem 11, we have covered VT, right? Then 12, we have almost covered everything. 14, yeah, vectors and coplanar forces, we have covered that. Then 15, we have jointed rods. So nearly 3 questions. So we have to do Bose notation and at least probability and stat by April. Meantime, we have to cover matrices and binomial expansions in PO, right? Then we have to do 13 and 16. And I have to do this online, like uh, field to acceleration. Uh, on Wednesdays, we have to do 13 and 16. That is simple harmonic motion and center of gravity, right? Okay. Because you have an enormous potential, so it's my responsibility to cover everything as soon as possible, right? Uh, so next day we'll start either probability O in this class, right? Probability O, uh, Bose rotation, right? But I'll be doing the probability next Wednesday in singular William class. It's a most probably it will be a YouTube live, right? If you want, you can join that. But it will be little harder for you. But those days, before I started, before starting English medium classes, like in 24, 23, and 21, I had district firsts from English medium. But those students attended for my singular medium class, so it won't be a big deal. Uh, Somehow, since we are registered for English medium class, I have to cover everything in English medium, right? That is there. So by uh, 30th of April, we'll cover these three for sure. Hmm. Then we'll be in a good shape, because on the other hand, we have covered almost 5 problems in pure math, right? Then in pure math, we have to cover only those two, complex numbers and uh, coded geometry. So here we have to cover simple harmonic motion and center of gravity. Okay, so we'll do one more problem. Okay, you first copy this down. Okay. Now we'll do different problem now, where the friction is involved. Two m is the particle with mass 2m. I don't want to be too wordy there. Now here we have a little problem. There's a friction. So we'll see what we can do. It's kind of a pulley with mass 2m. Now this is R, and clearly this moves in this direction. So this is mu R. Since mu is half, it is half R, 1 times R. This is 2mg. Its acceleration is F2. Now we have a little problem. We have two accelerations, F1 and F2, right? We have two accelerations and one tension. However, there are only two particles moving. Therefore, you have, like if you apply F equals ma, you get two equations without reactions, two equations, usually, without this fact, two equations. Uh, However, you need a third equation because there are three variables. So you use derivatives. Take this length as x, take this as y. Now this is a fixed length, I'll take it as L. So x plus y, which is 2y, plus L is a... now you can differentiate with respect to t, then this will be x double dot plus 2y double dot. Now this is a constant, so it will be 0. This also 0. Now, by looking at the direction, now F1, if this moves in the direction indicated by F1, x is reduced. So it has a negative connection. Now this is y, so y double dot is plus F2 because if this takes this direction, y increases. Now if you plug in this, you have minus F1 plus 2F2 is 0. This is equation 1. Now, what about the other equations? You can apply a few equations, but you get R involved. We'll see. So we'll try to apply the equations as usual. Now, if you apply Newton's law this way for mass m, you have T minus half R. I mean, the same is true if there's a friction involved in a wedge. Say that they say a wedge is placed on a table, and if the table is rough, there will be a friction. So again, you will encounter this situation, m times f1. Then you have to apply an equation to this. For 2m, it is 2mg minus 2t, sorry, is 2m times f2. Sorry, this is equation 1. So this should be equation 2, this is equation 3. Usually we apply these equations without the reactions getting involved. But the problem is in this case, you have a reaction here. So you need an extra equation. Like if this happens in the problem of a wedge, due to the friction, you get that reaction in that particular equation. Therefore, you have to come up with another equation for R to replace R. So that means you have to apply something vertically. I forgot to write mg. Sorry about it. So we'll apply again Newton's law because it's moving. So we have R is equal to mg or R minus mg. Along this side, the acceleration is 0. So R is mg. Now, if you want to find, okay, using this, you can find t. Because how many variables are there? F1, F2, T, and R. R is there. Now you can replace R by that. If you happen to encounter problem where the wedge is placed on a rough table, then again you apply the equations in the regular fashion. However, in one equation you get R. To eliminate or to find that, you apply a vertical Newton's law vertically for that wedge. Right. Now we'll solve. Now we need to find T. So again, you can make F1 the subject and replace it by, replace F1 by that. Make F2 the subject, replace F2 by that. Make a use current. So substituting, first we have to write this by solving equations 1, 2, 3, and 4. The tension can be found. Right. Now we'll now find the tension. So substituting, now how can you do that? F1 and F2 can be made the subject, and you can write it in terms of T, forget about R. Then you substitute them here. Now R will be there, replace R by mg, right? Substituting 2 and 3. In equation 1. So you have 2F2, right? 2F2 is F1. Now what is F2? F1, okay, F2 is this. 2mg minus 2t divided by 2m. 2mg minus 2t divided by, oh, it's weird. Would have been divided by 2 anyway. Anyway, I could have divided it by 2. Shall I do that? Otherwise, it's kind of funny. It looks funny. mg minus t is mf2. Now, f1 is half minus, sorry, t minus half, 1/2 times r divided by simple lim. Right? So that's what we have. You can multiply the entire thing by m. Now R can be replaced by mg. Now you have 2 mg plus half mg. Here you have minus 2t. If you bring that to that side, if you take that to the other side, it will be 3t. You have 5 mg over 2 is 3t. This is the tension, right? Remember that, please note that if you happen to encounter a problem where the wedge is on a friction, on a rough surface, then you apply the equations in a regular fashion, then apply Newton's law vertically to get another equation. Then using that, you can find R, the unnecessary uh, quantity or unnecessary variable, right? Okay, you take this down. Right. Basically, that's it. So in the third problem, you get something like this. Usually, you get something in which you have to obtain an equation using derivatives, the extra equation. Now you know how to count that. Count the number of tensions plus, usually there's only one tension, plus the accelerations. If that is equal to the movable objects, then you can just straight away apply F equals ma or the Newton's law. Otherwise, using derivatives, you find the extra equation. Then you apply Newton's law as we did here. And I think we have to do one more. Now, that's all. Now, if you want to find any acceleration, now you can substitute the tension here. If you, if you want to find F2, you substitute it here. If you want to find F1, you substitute it here. Right. So basically that's it. And I have the tutes printed, but since you don't come these days to the class, I can send the PDF. I'll do it tonight. Uh, so we'll start a new section in applied next day. That is next Wednesday, right? Meantime, we need to have some extra session. I can easily finish probability, stat, and Bose notation by 30th of April. That is 4.5 problems in applied. So if we cover 6 problems by May, we will be in real good shape. 6. I think we should be able to do that. Right. At the same time, we have to cover 6 problems in pure math by 30th of May. There's 6. We have only one problem left, and we have 2 months, and one problem from each section. Right. I'll do it like that. I will probably have some extra classes in April. Then we'll be in a good shape. So don't worry. Yeah? I'll definitely do it like that. Okay. Don't postpone things. Huh? Okay. I'll watch the other video next week or week after the next. Then you will miss it. Right. So do everything on time. And it's kind of little unfortunate that we miss each other, but can't help. That's totally beyond our control. ඒක කරන්න දෙයක් නැහැ නේ අපිට. ඒ නිසා අපි මෙහෙම කරමු. ඒ කියන්නේ මම කොහොමත් 4.5 problems cover කරනවා. ඒ කියන්නේ probability stat and what else? Bose notation. ඒ කොහොමත් cover කරනවා. ඒතර අපිට එනවා probability and 20 marks. Sorry, probability stat වලින් 20, Bose notation වලින් 7.5. So altogether 27.5 cover වෙනවා applied වල එතනින්. Then we can cover either SHM or center of gravity in March. Sorry, in May. Then we have SHM, center of gravity, and